Hello everyone, in this video we are going to be looking at the derivative of a sum, and we are going to be looking at few examples. The first example here says we should find the differentiation of y equals 2x to the power of 3 minus 5x squared plus 2. So when we say derivative of a sum, we are going to be given the sum of different functions, and as you can see here, y is the combination of the sum of three different functions. So this is the first function here, this is the second function here, while this is the third function here. So when we have the combination of more functions being added together or subtraction between them, how do we get the differentiation? It's very simple. It's just using differentiation with second principle. Like I said, we are going to be continuing to use differentiation using second principle. So all we just need to do is we differentiate each function individually, one after the other. That's how you go about differentiating the sum of different functions. Now let's move into action. So to get the answer to this, it's easy to see that the y dx equals, so don't forget, all we need to do is multiply the power by the coefficient. And in the first function here, the power is 3 and the coefficient is 2. So all we just need to do is multiply 3 by 2. So we have 3 times 2 as 6. Then we have x. We reduce the power by 1. That's going to be 3 minus 1, and that's 2. So we have 6x squared. Then we have 2 multiplied by negative 5, that's negative 10. So we have minus 10, then x to the power of, we have 2 as the power here. It means 2 minus 1, and that's 1. So I'm going to leave it as negative 10x. Then the differentiation of constant is always 0. Please take note of that. Differentiating constant is 0. So the final answer is 6x squared minus 10x, and that's all about it. Now let's talk about the next question that I have here. It says we should differentiate y equals 3x squared plus 1 over x. Please don't forget, I'm going to be writing 1 over x as I have here in exponent form. And how do I write it in exponent form? So it becomes y equals 3x squared plus x to the power of negative 1. So I've written it in exponent form, then I can get the differentiation. Say, oh, the y dx now equals, multiply the power by the coefficient. 2 multiplied by 3 becomes 6, then x to the power of 1, because you're going to be subtracting 1 from the power. Then we're going to be multiplying the power here, which is negative 1, by the coefficient. It's going to be minus x to the power of minus 1, then minus 1. And we already know that minus 1 minus 1, that's negative 2. So all I just need to write is negative 2. And this is the final answer to this. Now let's progress into the next example that I have here. It says we should get the derivative of y equals x cubed plus 2x squared plus 1 all divided by x. Now when we have situation like this, as you can see, we have expressions for the numerator, and we also have an expression for the denominator. And it is easy to see that we can divide all through by x, as in this case, because the denominator is x. So all we just need to do is divide each of these by x. Now let me quickly get the simplification done. So we have this expression can be written as y equals x to the power of 3 divided by x. I could have done everything straightforward, but I just had to simplify them one after the other. So plus, so we have 2x squared divided by x, then plus 1 also divided by x. And from here, we know that x here is going to be 1. Then x in x cubed is going to give us x squared. We have x here is going to be 1. And we have x in x squared is going to give us x. Then we also have 1 over x. Now let's quickly get that simplified. So we have y equals x squared plus 2x plus 1 over x. Of course, I'm going to be writing 1 over x in exponent form. So this becomes y equals x squared, then plus 2x, so plus 2x, then plus x to the power of negative 1. Then from here, I can differentiate. Now let's get the differentiation done. So I would say the y dx so the y dx equals, then I'm going to be writing 2x, because we're going to be multiplying the power by the coefficient. Then we subtract the power by 1. So that's 2x. That's me simplifying this to get 2x. Then also differentiating this is going to give me plus 2. So we have plus 2. But the differentiation of this is going to give us negative x. Then I'm going to be subtracting the power by 1. So negative x to the power of negative 2. So it's going to become minus x to the power of minus 2. So the final answer is this. So let me write properly. So we have the y dx equals 2x minus x to the power of negative 2, then plus 2. So this is the final answer. So do well to understand this properly. Now let's move to the final exercise that I'm going to be solving here. It says y equals root of x plus 1 over root x minus 3. So all we just need to do is we need to further rewrite this function given to us. So I can write it as y equals root of x is going to be written as x to the power of 1 over 2. X to the power of r is the same thing as the root of x. Then plus, this is going to become x to the power, we have plus x to the power of negative r. X to the power of negative r. Then we have minus 3. So we have been able to rewrite the question given to us. Then from there we can differentiate. So we have the y dx equals, we have half x to the power of negative half, because we're going to be subtracting 1 from the power we have here, which is half minus 1, and half minus 1 is negative half. So we progress. So we have minus half, because we're going to be multiplying the power with the coefficient that we have here, which is 1. So we have minus half, then we have x to the power of minus half minus 1. Now, in this case, minus 1 and minus half is going to give us minus 1 and a half. And minus 1 and a half is negative 3 over 2. So we have negative 3 over 2. And don't forget, the differentiation of constant is 0. So the final answer is what I have here. It says half x to the power of negative half minus half x to the power of negative 3 over 2. Please do well to subscribe, to like, to share, and to comment. Anticipate for more videos. So the next video we are going to be looking at, the next topic we're going to be looking at in the next lesson is going to be chain rule. Chain rule. Chain rule of differentiation. It's also called the function of function. The function of another function. We can as well call it the chain rule. They are the same thing. Please do well to anticipate. You are great.